This lesson is on vector motion, polar coordinates, and graphs. The first thing we're going to talk about is vector motion. These are FRQ examples. So these are all calculator active. A particle moving the xy plane has a position of x of t, y of t at time of t, with the derivative of x with respect to t as sine of t cubed and cosine of t cubed. At time t equals 2, the object is in position 7, 4. So the first thing we're going to do is write the equation of the tangent line to the curve at the point where t equals 2. And with that, we're going to do the dy over dx, which is the slope. And we are going to take our known sine and cosine. We're going to divide those. So cosine of t squared on top, sine of t cubed on the bottom. And again, when we do dx over dt, dy over dt, these are going to cancel out. So that's why we can do the x and the y. Well, I guess the should be y over the x, but anyway, same thing applies, where we just have the dt cancel out, and we're going to evaluate that at t equals 2. And again, this is a calculator active question, so we're just going to plug in cosine of t squared is 4, and then sine of t cubed is 8. We plug that into our lovely calculator. It's gonna be a lot of back and forth today. Cosine of 4 divided by sine of 8. And we're going to use negative 0.66067 if you want to round it a little bit. But I usually say go to 4, and you can round the last one. Negative 7. And we need to find the tangent line. We already found the slope, which is my m value. And we have y equals my slope, x minus my x value of 7 plus 4. And where I'm getting those from is this coordinate point. And that's my first answer. B, find the speed of the particle at 2. The speed equation is the square root of dx dt squared plus dy dt squared. And we're just going to plug those in with respect to t equals to 2. So our speed is going to be sine of 8 squared plus cosine of 4 squared. And if we were to plug that into a calculator, it'd be 1.186. I'm not going to show that because you can believe me. Okay, C, for what value of t 0 to 1 does the tangent line of the curve have a slope of 4? Find the acceleration vector at this time. So I do have these two pictures right now, but our first is going to find where the slope equals 4. And we know that from the beginning, we have the slope as cosine of t squared over sine of t cubed. And when I plug that in to Desmos or calculator, does not matter if you do a TI calculator, whatever calculator you have, you should get the same answer. Desmos is just a little bit easier to show on the iPad. And that'll be 61649. Now what we're going to do is we are going to find the acceleration. So the acceleration is going to be the derivative. And we know that because it goes from position to velocity to acceleration. And we already have the movement of it. And so we're just going to take the derivative. And what I did here is I took the derivative of our sine. I used x instead of t because when we do it on Desmos, it really doesn't like other variables. And so I did sine of x cubed, and then the derivative, and then the derivative of cosine, and then set x equal to our value that we just found. These are the same. And I found that my acceleration vector at this time is 1.109 and negative 0.457. If you want to include the entire decimal, that's okay too. That's what it gives you. You can use that. Some people, I did round if you didn't put these two at the end. It kind of changed it just slightly, but not that much. This would get you full credit. And we know that this is x because the sign at the beginning was dx over dt. This is dy over dt. So that's why this is in the quote x place and this is in the y place. And the last one, find the position of the particle. So that means we have the velocity, so we have to take the integral. And the integral, we already know at t equals 2, the particle, I cannot spell, is 7, 4. So I already have x equals 2, right? But just first, setting up my integral of this. And we know that's going to be x2 minus x1. And we already know that our x2 value right here is going to be 7. So I'm going to solve for my x1. Let's just put a little curly bracket here. This is just my work. So I'm just going to kind of swap those out. So I have x1 equals 7 minus the integral of 1 to 2 of sine t cubed dt. And we can use a calculator for this. And we'll get 7. If you wanted to just jump this step, you could. 2181 or 6.782. And since it is a calculator active question, they will expect you to get the actual answer. So make sure you put that. And then we also need to find the respective y value. Same exact setup, but we're going to this time use our cosine of t squared dt. That'll equal y2 minus y1. And again, we do know that our y2 is 4. So zoom this in here. Again, same exact setup. And plug into a calculator and it will get you 4.4431. And we do need to put it into a position vector. So make sure that you, at the end, put it all together, because it's great that you did all the work, but you just need to answer the question, right? They want a specific point, and your position vector will be right here. So just make sure you answer the question that they're asking. Okay, another calculator active question. This one's a little bit easier, but a particle is moving in the xy plane, has a velocity vector given by this lovely thing for time t equals greater than or equal to 0 seconds. Is the horizontal movement of the particle to the left or to the right at time t equals 2? Explain your answer. Okay, remember to explain, right? If they tell you to explain, you gotta explain. So what we're gonna do is we want to look for a horizontal movement, and we know that's the x value. So I'm going to do the quote unquote x value, sine of t equals to 4, and that will equal negative 0.757. And it's left because the x left because v2 has a negative component, negative x component. So we got our explanation. So we found it. And then we explained it's left because it's going negative. B, find the slope of the path of the particle at t equals 2 seconds. So same thing as the last one. We have dy over dx. And just like I said for the last one, even though I kind of said a little wrong, it is dy over dt and dx over dt, and these dt's will cancel, so they're really not too significant to us, but we are going to divide e cosine of t and sine of t squared, and we're going to evaluate that at t equals 2, and we will find our slope is negative 0.8715. We weren't asked to find a tangent line, we were just asked to find the slope. C, at time t from 0 to 4 seconds is the speed of the velocity 2 units per second. We weren't given any units, so we're just using the generic units. So we know speed is 2, and we're going to equal that to our speed equation, which we know is dy over dx over dt squared plus dy over dt squared. We're just going to plug in the things that match there. And what we're going to find is plugging into a calculator, nice and easy. Again, in our specific interval. Okay, so doesn't really like us right now, but the only place where it exists from 0 to 4 is right here. And if it had let us click on it, which I don't know why it won't, it gets a little rude sometimes, but we would find t equals to 0.898. So that's at that time, seconds. Last one, D, what is the magnitude of the displacement of the particle between t equals 2 and t equals 3 seconds? So we're going to find arc length. Might be asking, why are we doing arc length? Well, oops, sorry, this should be a 2. Oopsie. And that is because, oh my goodness, what is with me? 2 to 3, the absolute value of velocity, it equals displacement, and speed is velocity. So that's what we're looking for. And that's why we have the absolute value, it has to be positive, right? Because it's inside of a square root, so it has to be positive, or else we're dealing with some imaginary numbers, which we do not want. But if we plug this into our lovely calculator, it will give us 0.878 as our answer. So this one's a little bit tricky just because it doesn't really tell you what it's looking for. It's saying the magnitude of the displacement of the particle, magnitude, and we'll just start with the displacement is the same thing as the absolute value of velocity, and velocity is speed, so that's why we have this whole thing set up. So it's a little bit more complicated than some of the other ones that we were given, but these are the kind of ones where they're really asking you to think very clearly. Okay, so polar coordinates and polar graphs. Rectangular coordinates, Cartesian, right? X comma y. Polar coordinates are in the form r comma theta. Example 1, let's graph the following polar coordinates. A, so we have r comma theta. We have 4, which is our r value, and 2 pi over 3. So first thing we're going to do is we're going to find 2 pi over 3 right here. Then we're going to start here in the middle, and we're going to count 4. So we're going to go 1, 2, 3, and 4. And that's it. That's my A. B, same thing. So we find 7 pi over 6. And then we count from the middle. 1, 2, and 3. That's my B. C, we have -2 pi, 5 pi over 4, sorry. What that means is just we're reflecting over the pole. So instead of going towards the 5 pi over 4, we're going to go in the opposite direction. We're kind of going to flip over. So let's see, 5 pi over 4, right, is right here. And we would just be going in the opposite direction, 1, 2. So this is the equivalent of saying 2 pi over 4. So we're just kind of using, where's the, so this, not that one. Sorry, like this. So we're kind of reflecting it over that pole. So we're just going in the opposite direction. We're going away. And then our last one, I should put a C. And we have 2 negative pi over 6. So we're going to go clockwise from theta equals 0. And we're going to start here, and we're going to go negative. I'm going to go clockwise. And what we have is negative pi over 6. So we'll look at 11 pi over 6, right? Because 12 pi over 6 minus pi over 6 equals 11 pi over 6. And then we will go over 2. So we count 1, 2, and we put a dot. And that is how you graph polar coordinates. Pre-calculus and kind of geometry, right? Because we are using the Pythagorean theorem just slightly, and then some SOHCAHTOA. But we're using r in this context as our hypotenuse, and we have cosine of x over r, y over r, y over x. We know this. And we have x squared plus y squared equals r squared. Now we're going to rewrite them as r equals square root of x squared plus y squared, x equals r cosine, and y equals r sine. And we're going to need that for the next couple of problems we're going to do. So we're going to convert into rectangular coordinates or Cartesian to polar, and then polar to Cartesian, and back and forth. So just to remember, I like to rewrite everything cosine, and the only reason I remember cosine and sine corresponds to x and y is because the alphabet, because C comes before S, and so does x and y. So, I mean, if that helps you remember it, that's how I remember it every time. And now we're going to convert 5 pi over 6 to rectangular coordinates. So x equals 2. So remember, this is my r value, and this is my theta. Cosine of 5 pi over 6. And you should not be using a calculator for these. You have to know what 5 pi over 6 and for sine and cosine is. You've got to memorize the unit circle. So we have 2 times -3, the square root of 3 times 2 equals negative square root of 3 times 1/2 equals 1. So we have negative square root of 3, 1 as our answer. And there we go. Example 3, convert 3, -3 to polar coordinates. So we have x equals 3 and y equals -3. And since we're given x and y, I can use that to find our r value. So we have r squared equals x squared plus y squared. And I know that's going to be 18. And r is going to be plus or minus 18, or square root of 18, my bad. Or plus or minus 3 square root of 2. And we're going to use that to be our x, or not our x, sorry, our r value. And then we have to find the theta. So I'm going to do tangent of theta because we are given an x and a y. So I have -3 over 3, and that's equal to -1. So the places where theta equals -1 for tangent is 3 pi over 4 and then 7 pi over 4. And when we do this, I'm going to draw just a little picture. So 1, 2, 3, 1, 2, 3. So we can also say this is negative pi over 4, depending on what you want to call it. But so you might be thinking, okay, so what is it? We have 4 different options here. Okay, so let's just think of this as a circle. So lovely circle, right? It's a little off center. A direction of we're thinking about these in circles and polar coordinates, right? And we're going towards 7 pi over 4. If we were to picture a unit circle, we go 7 pi over 4. And since we're dealing with a positive r value, quote unquote positive, right? We would say that my polar coordinate would be 3 square root of 2, 7 pi over 4. And you might be thinking, wait, we also have, it could be negative 3 square root of 2 and 3 pi over 4. Well, that's actually, so if we remember back to our example from example 1.3, when we have a negative, and we're going 3 pi over 4, these are actually the same thing. Because if we have, remember the opposite way of this, say this is 3 pi over 4, to go towards this direction would have to be positive. But since it's a negative, it would actually be going this direction. It'd be going away. So that's exactly what example 1c was saying. So these are the exact same point, just written differently. So that's why we are putting those with their corresponding counterparts. And if you were to use a calculator up here, this is for the TI-84 or whichever one you use. Make sure you have you hit second angle. It should say apps on it, and you just plug in our rectangular coordinate to the polar r that looks like an r, and then you can do the same for theta to find what the r value and the theta value is. And so this would give you the exact this red one up here, and again, there are 2 correct answers, just like we did for the example 1.c. Convert the following equations to polar form. Y equals 4. We already know what the y value is. I mean, nothing too crazy on this instance. We have y equals r sine of theta. Then we know y equals 4. And now we're just going to solve for our r. 4 over sine of theta equals r. And now we're going to set this equal to r, right? Because we know that r squared equals 25, because we said x squared plus y squared equals r squared. And then we have r equal plus or minus 5. So you can do it on a calculator. You can do both of these on a calculator. If you see my notes for the step-by-step instruction, for the TI 84, whatever it is, there are a couple of ways to do it on there. I am not super sure you can do them on Desmos right now, but this is how to do the 84 instructions. Okay, example 5, convert the following equations to rectangular form and sketch the graph. So we have our first one, r sine of theta equals 3. We know that r sine of theta is just our y value, so we just know it's y equals 3. So this one's really easy. We like that. And sketch the graph. We know y equals 3 is going to look like this. Okay, r equals 2 cosine of theta. So this one's a little bit tricky. And why is that? Because we know x equals r cosine of theta. I'm going to zoom in here. And we have x divided by r equals cosine of theta. We're going to have a lot of work to do. And r equals 2 times x over r. So we're kind of doing a lot of plugging in. So we know this is our given. We already know this, just knowledge. Then we plug that into original, and then we know that cosine equals x over r, so we plugged it back into there. So a lot of kind of substitution. Now we have r squared equals 2x. And we know that r squared equals x squared plus y squared, and that'll equal 2x. Now we have to complete this square. We have x squared minus 2x plus y squared equals to 0. X squared minus 2x plus 1 plus y squared equals 1. And we have x minus 1 squared plus y squared equals 1. And now we can graph this. This is a circle. My circle is going to be a little, there we go. Now we have theta equals 2 pi over 3. And we know that we can just throw in a tangent in there. Take a tangent of both sides, because this will help us find our x and our y value. We know that's y over x. And we know tangent is square root of 3 over 2, and then negative 1 square or over 2 equals negative 3. And we will have y equals negative square root of 3x. And we can just graph that. I'm not gonna be super specific about it, but it's gonna be something like this. Again, it's kind of close to 1, so it doesn't have to be perfect, but that's how we convert following equations to rectangular form and sketch our graph. To find the slope of the tangent line to the polar graph, r equals f of theta, we can use the facts that x equals r cosine of theta and y equals r sine of theta together with the product rule to find this. And we must use the product rule because r is not a constant. It's not a constant. It's a variable depending on theta. It can change. It can get bigger, smaller. It's another variable, just like x or y is a variable. So using this, there is calculating instructions here, but find dy over dx and the slope of the graph of the polar curve r equals 3 plus 2 sine of theta at theta equals pi. So we know dy over dx equals r cosine of theta plus sine theta r prime, and then negative sine r sine of theta plus cosine of theta times r prime. So we know r equals 3 plus 2 sine of theta. Take the derivative of that, and we have 2 cosine of theta. And now we can evaluate it at pi for each of these. And when we have r of pi, we have 3 plus 2 sine of pi, which is 0, so we just have 3. And then r prime at pi, and that'll be just negative 2, because sine or cosine of pi is negative 1 times 2 is negative 2. Now plugging that in, so we have 3 times negative 1, because we're evaluating it, sorry, at pi, plus 0, negative 2. And then we have negative 3 times 0 plus negative 1 times negative 2. Again, I'm just solving a little bit bigger. Just putting things where they belong. So if you're confused on where I'm getting anything from, just look at the corresponding information, right? This is just sine of theta, right? If we're evaluating sine of theta at pi is just 0. And same thing here. And then cosine as well, which we know is -1. And then the 3 and -3 are from this 3 right here. And it's only negative because we have the negative out front when we took the derivative of our cosine. So when we simplify all of this lovely stuff, right, we get a lot of zeros. We love zeros. -3 over 2 equals our slope. And this is on a TI 84 calculator. So you would have to put your calculator in a polar format. And then you would do, I can't show you because I don't have a TI 84 on the iPad, but you just plug in all these steps and you should be able to easily evaluate it. So you can put your calculator in polar mode, radian mode, and all that lovely stuff. It's POL on the TI 84. So this one you should do yourself with no calculator. Do not use a calculator. This one is from example 5. That's why I say see example 5. And you should be doing these by hand and not plugging into the calculator, with the example 5 being your reference. But pause it and do yourself. So you should have done it. Just check your work real quick. So check your answers. You should not be using a calculator for these. You should be doing these by hand because some on the AP test will require you to use it by hand or will ask you to do it on a calculator. So the next ones are just to plug it into Desmos, and the max and min corresponds to your TI-84 or whatever calculator you're using, but Desmos is a lot easier for me to screenshot, so I included the screenshots here.